Alright, let's get started. We're gonna start with some easies. We'll do longest common prefix. Write a function to find the longest common prefix. If there is no common prefix, return empty string. So we go through each string and find the longest prefix of all strings. Yeah, we're going to be doing this in JavaScript. And let's start with a simple solution. Maybe we could figure out a more advanced solution after that. So we'll do for let I equals 0, I is less than striz.length I plus plus. Actually, say I don't know when this will stop, to be honest. Instead, we'll do for let j equals 0, j is less than length j plus plus. And so we're gonna have two loops here. This loop is like track the length of the prefix so far. And so the length of the prefix is 0 so far. And we'll actually start j at 1. And it might be good to get the length of the shortest string in the list. Let's just do this for now, and then we'll think about edge cases. So pretty much what we're going to do is just for sanity, we'll do strings sub I sub j minus 1, and b is strings at I sub j. And pretty much if a is not equal to b, then we'll return I, because that's no longer, we do I minus 1. We actually had to do string sub 0 dot substring from 0 to this. And at least be 0. And I think we should probably A at, if not A or not B, or A is not equal to B, just in case we go out of bounds of the string. And this one, track the string we are looking at. Alright, so the idea is we're basically gonna go forever. There's always at least one string, and each string is 0 to 1, 0 to 200. and only lowercase English letters. So we basically go through each string and or actually basically go through like each character. We're building up a prefix, and for each string we compare it to its previous string and see if that they are long enough to even have a prefix, B that they are B is also long enough to have a prefix, and that and see if they're not equal, because if they aren't long enough or they're not equal, that means that we've found the longest prefix. So I was gonna, and we do this max here just in case I is 0. For whatever reason we find no prefix pretty much, and we have to return an empty string. So just run it, see what kind of result we get. Okay, well, we get an empty string for that result, and we get an empty string for this result, which is interesting. We're gonna console log, just console log everything, I guess. ABI and J. So we're looking at the wrong thing here. This should be I, because that's the character. Okay, so this one should be getting to the L. So I is 2. And J is 2. So we're looking at and then A is O. So we're comparing this O and this I. And we're finding out that they're not equal. Maybe we don't minus 1. Yeah, maybe we don't minus 1. Because we only increment I when we're successful. Okay. So let's see if there's any follow-up. There's no follow-up. So one thing we want to consider is there a way to run this a little bit faster? Let's submit it and see the performance at the moment. If we're really high tiered, then we probably don't have to worry about optimizing. Because we are hitting a time limit somewhere, which means there is an optimization that we could do. Okay, so for the input of an empty string, we exceed the time limit So let's think about that. Okay, so we would never execute this for loop if that were the case. So pretty much we need to add an edge case here. If strings.length equals 0, then we'll return strings sub 0. Just to handle this edge case of there's only one element, so the prefix, it is the prefix. Let's run it just to make sure we're still passing. Let's submit it. Sorry, length is 1. Okay, and we're pretty slow. We're at 2 milliseconds, so we could try to think of some ways to improve it a little bit. So, one thing that comes to mind is maybe not doing this every single time, and this could be just 0. No, yeah, this could be I, this could be 0. I don't think this improves it that much. See if we can think very deeply about this. Usually if you want to try to improve a little bit, you want to try to use like a map or a set or something, some kind of data collection that's a little bit more optimized. You pretty much use some kind of memory to cache some data, but nothing's really coming to me. Because yeah, it's not like we're really looking at anything more than once. And the only way I can really think is to just look at each individual character. Just for the lulz, I guess. See if this helps us at all. Try to index less. There's no way this improves it. So we're beating 42.68%. There's no way we get down to 1 millisecond from just, oh. Interesting. There's a way to get 0 milliseconds though? That's kind of crazy. Well, anyway, it seems that caching is a good way to go. Don't use don't index too many times if you can avoid it. I feel like we could also do this. Then we don't even need to do that anymore. Because if we have A, if we don't have A, then we're done. But if we do have A, then we'll have a string with a character in it. Which means that if B is null or undefined or whatever, then it will not be equal. So this should also be slightly better performance. Still 1 millisecond though. Okay, well, I actually don't know if we're being compared against other programming languages here. Oh, is this a solution? Will they use recursion? What does this do? What's the slowest? Oh. This is really hard to read. Okay, well. So, this is interesting. We did have this base case in ours. Apparently this JavaScript runs faster than our JavaScript. Prefix 0 sub 0. Turn fn. This value is going to change, which is kind of crazy. In my opinion, you're kind of sacrificing readability for performance, which is usually not ideal. But we try to understand this code anyway. Index prefix.length -1. So kind of working your way backwards. Characters prefix index. It's just getting the last character. And then we're gonna go through the rest of the strings and find character at I, the string at I, which is the word. See if the index, okay, so if the index is greater than the word at length, or if the character, okay, so this is like saying, okay, I've kind of given up, I'm done, I found the answer. But it's starting from the back and working its way forward. So it's able to do it, and it's not a match. If index. Ooh. I'm surprised that something like this, doing something like this and doing recursion is more performant than what I did. Ooh, what a doozy. Okay, well, anyway, back to my code. I'm happy with that.